Simultaneous equations are when two statements must be true. So, say x is equal to 1 and x is equal to 2. And the sign for simultaneous equations is this. So this is not used in the GCSE as much. It's usually used in IB or further pure mathematics. So say x is equal to 1 and x is equal to 2. Now, simple question. Can both of these statements be true at the same time? And this is exactly what the simultaneous equation is implying, that both of these statements are true at the same time. So can x equal 1 and 2 at the same time? Well, of course it can't. Therefore, it's just an empty set. It's impossible. Okay, so that's basic simultaneous equations. Now let's have a look at examples of questions with simul equations. So then 3x plus 2y is equal to 5. So simultaneous equation. There. 2x plus y is equal to 3. 3x plus 2y is equal to 5. These two are both true at the same time. So, how do we figure out the values of x and y? Pretty simply. First, let's express y in terms of x. So how do we do that? Well, in the first equation, we just subtract 2x. Subtract 2x over here, which get rid of this, which leaves us with y equals 3 minus 2x. So let's write that down. Usually what I do is I put a little arrow, and I say y is equal to 3 minus 2x. Nice. So, now that we know that y is equal to 3 minus 2x, according to the first equation, we can now substitute y into the second equation. So, now that we know that y is equal to 3 minus 2x, we can say that based on the second equation, 3x plus 2 times 3 minus 2x should equal 5. Again, how did I get that? I just put y, the value of y, over here. Now let's just solve this linear equation. 3x plus 6 minus 4x is equal to 5. I just expanded the bracket. Now you get negative x is equal to negative 1, x is equal to 1. So now we know the value of x, and this is where many students stop, and for this they get half the marks. Why? Because you're told two numbers to figure out, x and y, but you figured out only x. So what do we do now? We substitute x equals 1 into one of these equations. It doesn't really matter, both of them are equal. Both of them are true, sorry. So we can say that 2 plus y is equal to 3. What did I do? I substituted x equals 1 into this equation. So, therefore y must equal to 1. You just subtract 2 from both sides, y equals 1. So the solution to this simultaneous equation is x equals 1, y equals 1. Let's just draw this a square. There. Now, this is very simple to check. You just substitute the values x equals 1 and y equals 1 into both of these equations. So here, this is just 2 plus 1 is equal to 3. 2 plus 1 is equal to 3. And 3 plus 2 is equal to 5. 3 plus 2 is in fact equal to 5. So the solution must be correct. Okay. Let's have a look at slightly different ways to solve simultaneous equations. So let's have a look at 2x plus 3y is equal to, let's go, I don't know, 11. And 2x plus 2y is equal to 10. There. So now what you might be able to do, and this is a simultaneous equation. Now what you might be able to figure out is that if these two statements are true, then what we can do is we can just subtract the second statement from the first statement. So how does that look like? 2x plus 3y minus 2x plus 2y is equal to 11 minus 10. So what did I do? 2x plus 3y is equal to 11. This is the 11 right here. 2x plus 2y is equal to 10. This is the 10 over here. What I did is I subtracted this from this, which effectively is equal to 11 minus 10. Nice. So now what do we see? We see that 2x plus 3y minus 2x minus 2y is equal to 1. And this is the key point over here. These two cancel out. And we are left with y is equal to 1. Then you just plug in the value y equals to 1 into one of these equations. Let's put it into the top one. We get 2x plus 3 is equal to 1. Therefore, 2x is equal to, no, equals 11, sorry. Therefore, 2x is equal to 8. Therefore, x is equal to 4. Done. So this way is a more advanced and I'd say a more smart way to approach simultaneous equations, is when you can get them to have a common, let's call it, it's when you can get them to have a common digit, like here, like 2x, or even if we added 1 over here and added 1 over here, then you would get that 2x plus 2y plus 1 is equal to 11, and 2x plus 3y is equal to 11. So therefore, we can simply say that 2x plus 2y plus 1 must be equal to 2x plus 3y. And that's it. So you could also do that. You can make these two equal, therefore making these two equal as well. It's a nice and neat way to solve these. Okay, let's have a look at something more complex. And this is more maybe 5 or 4 mark questions in the GCSE. This is where they start to put in quadratics. Let's go 3y plus 2 is equal to 5y. Let's just scribble that out. And x plus 2y is equal to 3. Okay, how to solve this? Now we can go in 2 different paths. One path is short, the other path is immensely long. And students, for some reason, usually choose the second path. So the first path is to express x in terms of y. So in this case, say that x is equal to 3 minus 2y, and substitute that value into each one of these, and then solve the quadratic. Now, this method works, and it's perfectly fine to use it. However, there's a method much simpler. So the method that I'm talking about is expressing y in terms of x. Now, this is a bit counterintuitive because over here it's easier to express x in terms of y, but let's have a look at how many steps that will take us. So first of all, let's label this equation 1, let's label that equation 2. First of all, let's work with equation 2. So 2y is equal to 3 minus x. I subtracted x from both sides. Now, from that, we can say that y is equal to 3 minus x divided by 2, which is equal to 1.5 minus 0.5x. Okay, now if we substitute this value of y into this equation, we should get quite a nice and neat quadratic equation. Let's have a look. So now working with the second plus the first, get that x squared plus 2x plus 4 point, actually, let's just do that. 3 times 1.2 minus 0.5x plus 2 is equal to 5 times 1.5 minus 0.5x, close bracket, there. So now this is very long, but we can simply make it shorter. So first of all, let's expand all of the brackets. X squared plus 2x plus 4.5 minus 1.5x plus 2 is equal to 7.5 minus 2.5x. Now, let's continue, and let's just carry stuff along. So plus 4.5 x minus 1.5x plus, so by adding this one and this one, we get 6.5. 6.5 minus 7.5 is -1, so we get -1 over here is equal to 0, there. Therefore x squared plus 3 minus, plus 3x minus 1 is equal to 0. Beautiful. Now let's try to factorize it first. I will do a video on factorization and how to factorize slightly later. And yeah, I don't see how you can factorize this nicely. So let's just use the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac. Now ac is -1, so 4ac must be minus 4 times a times c, is minus 4 times -1 is 4. I think that part was absolutely, okay, that part was absolutely not needed. Okay, so, and all of that over 2a. So over 2, which is equal to -3 plus or minus the square root of 13 over 2. There. So these are the two values of x, and what you would do is you would just plug in those two values of x into, say, this equation. Okay. Now, these were the two different types of simultaneous equations that you get, and two different approaches how to solve them. Now there's a third approach, which you need to know for the GCSE, which is the graphical approach. So let's have a look at the following equations. 2x is equal to y, and y is equal to 3x plus 1. There. Now, when you're solving using a graphical approach, you're trying to draw. No, that's not right. You're trying to draw the graph. The graphs of these two equations. And in theory, if you have a solution, those two graphs should intersect at a certain point, because both of the statements are true. Boom, okay. So 2x is equal to y. Now how do we draw that? The y-intercept is 0, so I'll use red for this graph, and I'll use blue for this graph. So red, 0 is the y-intercept, and then you go on a slope of 2 over here and over here. Nice. And then we can just connect all of that up, and we get something that looks like the graph. And now the blue graph, y-intercept is over here. It goes on a slope of 3, so it goes over here, it goes over here, and then it goes down to, oh, sorry. And then it goes down to here. So the blue graph should look somewhat like that. Now we can see that there is one certain point where the blue and the red graphs cross each other. And that point is the coordinate, let me put that in black. That point is the coordinate -1, -2. Now let's take a moment and let's forget about this. And let's try to solve our Simul equation using the algebraic method, using the method that I showed you slightly above. There. So how would you do that? You would go, okay, so we know that 2x is equal to y, so then we can substitute 2x into y in the second equation. So 2x is equal to 3x plus 1. Now some quick rearranging, you carry the negative, actually you subtract 2x from both sides, you get 0 is equal to x plus 1. You subtract 1 from both sides, -1 is equal to x. Okay, now you plug in -1 is equal to x into this equation. 2 times -1 is obviously -2, so therefore y is equal to -2. And you might see a very interesting thing. The point that the two graphs were intersecting at had the coordinates x is equal to -1 and y is equal to -2. The two solutions to the simultaneous equations. The solution to the simultaneous equation. So this is the second way to solve them. And this works with quadratics as well. So let's say we had a quadratic like that going over here. And we had some sort of graph like that crossing it. There would be 2 points of intersection, one over here and one over here. And so you would still figure them out using either A, the graphical method, or B, just doing the algebra, doing the math. In the GCSE, they usually ask you to do both in the paper. So like they would tell you in, say, section, like in question 1 in subsection A, they would tell you to solve it algebraically. Subsection B, they would ask you to draw the graph, or they would ask you to draw the graph first and then solve it using the graph, one of the two. But either way, those are simultaneous equations in the GCSE curriculum. Thank you for watching, and we'll see you in the next video. Bye.